Welcome to ClickMyProject.com. Our project title is the Deep Curve MRI. That is the Deep Convolutional Curvature Transform based on the MRI approach for the early detection of the Alzheimer's disease. This is our abstract. A dynamic dual graph fusion convolutional network is suggested in this paper to enhance the accuracy of the Alzheimer's disease diagnosis. The key contribution of the paper also are as follows. The proposed architecture can dynamically adjust the graph structure for the GCN to produce the better diagnosis outcomes by the learnings. Optimal underlining the latent graph propose a novel dynamic GCN architecture which is an end-to-end pipeline for the diagnosis of AD. Incorporate a feature graph learning and the dynamic graph learning giving those useful features of subject more weight while reducing the weights of other noise features. Experiments shows that our approach has a great classification result in AD diagnosis while offering flexibility and stability. This process is implemented for the AD classification using the graph convolutional network structures like CNN and LSTM layer with the model in the training and testing, and deploy the model and getting the test image output, and then compare with the accuracy of the model for getting most perfect model for the medical image classification. Get the accuracy of the CNN LSTM layer. This is our objectives to improvise the accuracy of the comparison, to minimize the time complexity, to enhance the performance analysis, to implement the layer of the LSTM with the CNN model for more accurate value. This is our flow diagram from the image data set. First step is the data pre-processing. Here we use the resizing, denoising, and then the segmentation and filtering process. After the pre-processing, we move on to the feature extraction. In that feature extraction, what are the features extracted related to the classes is classified, and then after that data splitting. Here we split the data according to the training and testing, 80% and 20%. In classification, apply the CNN LSTM. This CNN LSTM is first 3 layers of the fully convoluted layers is designed with the flattened layer, and apply the dense layer for the classification of the classes by neurons. After that, prediction. We predict 4 classes and matrices like accuracy, loss, and confusion matrix. This is a system architecture from the image data set. Data pre-processing. Next one. After that module is the feature extraction, and then data splitting, and then in classification apply this LSTM algorithm, and then in prediction, performance analysis. Finally, we calculate the accuracy, loss, and confusion matrix. This is the use case diagram. From the user, we want to first select the data, unload the data, and pre-process the data by checking the null values, and then resizing, and then denoising. And then in feature extraction, split the data according to the train and test. In classification, apply algorithms. In prediction, 4 classes, performance, accuracy, loss, and confusion matrix. Here architecture from the start and the load data set. First one is the selecting data, and then pre-processing, and then extract the feature, and prediction, classification, and then data splitting. This is a sequence diagram. We divide our total process into 4 sequences. First is the starting, next is the pre-processing, next one is the classification, and then after one is the performance analysis. Select the data, load it, and pre-process it, extract the feature, split the data, apply the classification algorithm. Finally, we predict the classes and get the performance matrices of the CNN algorithms. After executing our code, the output will appear in the console. This is the all the data files we have written in the data set. After that, we have the what classes we have, that is mentioned here. And this one is the sample image of mild demand and empty and NT and then very mild. And here we have the total number of images is 6400. And here we split the X-train as well as Y-train. Here we further split it into the validation X-train and validation Y-train. After this, our mobile net features are extracted for the feature extraction, and this one is the Inception V3 model for the classification purpose. The first one is the none option, and then here we have the lot of layers to find out the classification, and here epochs are run for the validation loss and then accuracy, and then finally we get that total accuracy is here, and then this is the classification